Hello everyone, here is the video going over the Unit 1B test review for linear inequalities. So the first section of your review deals with the application portion of our unit. So for number 1, it says the ideal altitude of a plane is between 20,000 and 40,000 feet inclusive. So the first thing we want to do is we want to define the variable. I'm going to go ahead and let x equal the altitude. And we want x to be in between 20,000 and 40,000. So x has to be in between those two values. Now a key word is that it is inclusive. So inclusive means that we can actually include 20,000 and 40,000. So I'm going to go ahead and change my less thans to less thans or equal to. So again, that inclusive changes our less thans to less than or equal to's. Okay, number 2. Keith has $500 in his savings account. At the beginning of the summer, he wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? So we're going to go ahead and start by defining the variable. I'm going to let x equal the number of weeks. And let's write the inequality. So he has $500 to start, and he is withdrawing money every week. So when you withdraw money, you are subtracting from what's already in your account. So I'm going to do minus 25x, and he wants at least $200 at the end of the summer. So we want the amount in his account to be at least 200. So that is greater than or equal to 200. And now that we have the inequality, we can go ahead and solve. I'm going to start by subtracting 500 from both sides. That gives me negative 25x is greater than or equal to negative 300. And divide both sides by negative 25. Now, since we are dividing by a negative, that means we are going to have to flip our inequality. So this becomes x is less than or equal to negative 300 divided by negative 25 is going to be a positive 12. So that means he can withdraw money for at most 12 weeks. Which is exactly what I'm going to write for my sentence. Keith can withdraw money for up to 12 weeks. Or for at most 12 weeks. You can use that wording as well. Okay, let's look at another one. A taxi charges a flat rate of $1.75 plus an additional 65 cents per mile. If Erica has at most $10 to spend on the cab ride, what is the most number of miles she can travel? So I'm going to let x equal the number of miles that she can travel. And the taxi charges a flat rate of $1.75 plus 65 cents per mile. So plus 0.65x, and she has at most $10. So that means she can spend $10 or less. So that's going to be less than or equal to. Let's go ahead and solve. I'm going to subtract $1.75 from both sides. That gives me 0.65x is less than or equal to 825. Divide both sides by 65 cents. And we end up with x is less than or equal to 12.7. Now you do have to be careful with how you are going to round this out for your answer. So if we had x is 13, so she can travel for at most 13 miles. She actually does not have enough money for that because the most that she can travel is 12.7 miles. but we want to talk about the number of full miles that she can travel. So she can travel at most 12 miles. And again, this is because she won't have enough money to get to that 13th mile. So I'm just going to rewrite my inequality as x is less than or equal to 12 miles. It seems weird to round down because typically we do end up rounding up depending on our scenario, but again, in the context of this problem, it makes sense that we would have to round down because she would not have enough money. Whoops. Ignore that line or any random lines that end up showing up on your screen. Okay, Chris wants to order DVDs over the internet. Each DVD costs $15.90 and shipping the entire order costs $9.99. If he can spend no more than $100, how many DVDs can he buy? So I'm going to let x equal the number of DVDs. And each DVD costs $15.90 plus the shipping, which is $9.99, and he can spend no more than $100. So that needs to be less than or equal to 100. And then we can continue to solve. I'm going to subtract $9.99 from both sides. Then I have 15.9x is less than or equal to 90.01. Divide by 15.9. And we get x is less than or equal to 5.7. But again, I'm going to take this and I'm going to round it down because he can only buy at most 5 DVDs. Can't really buy 6 because he's not going to have enough money since he can spend no more than $100. So Chris can buy at most 5 DVDs. I don't know who buys DVDs anymore, but Chris wants to buy DVDs, so he's going to buy at most 5 DVDs. Okay. For the next portion of your review, it's just straight up solving inequalities and graphing them. So we're going back to what we did with equations. All of those different properties that we had for equations are going to be very similar to inequalities. So for the number 5, I have a 4 in front of the parenthesis, so I'm going to start by distributing. 4 times d is 4d, plus 36 is less than 68. Now I'm going to subtract 36 from both sides. That gives me 4d is less than 32. And divide both sides by 4. So I have d is less than 8. So now I'm going to take that and graph it on a number line. I'm going to go ahead and put my 8 right in the middle. I'm going to add some numbers on both sides. That way I can see what's really happening to my inequality. And when I do graph this, I need to pay attention to whether I'm going to have an open circle or a closed circle at my number 8. So if I look at my inequality, it says d is less than 8. So anytime you have a less than or a greater than, that's just going to be an open circle. If you have an or equal to, that is going to be a closed circle. And we want everything that is less than 8. So like 7, 6, negative 52, all of that is going to be to the left of 8. So that is where I'm going to shade or draw an arrow or whichever way you like to do your number lines. Number 6 is a compound inequality, and I know it's a compound inequality because I have 2 inequalities over here. So it's 2 inequalities put together. This is an and inequality because my 3x minus 6 is greater than negative 12 and it is less than or equal to 3. So I'm going to start by trying to figure out how to isolate my x. My x is being multiplied by 3 and I am subtracting 6. The last thing that I said is what I am going to undo first. So I said subtract 6. So to undo subtraction, I want to add. So I'm going to add 6. Now with and inequalities, you have 3 portions of your inequality. So whatever you do to one portion, you have to do to all three portions. So that gives me negative 6 is less than 3x is less than or equal to 9. And then from there, to get my x by itself, I need to divide by 3. And once again, what I do to one portion of my compound inequality, I need to do to all three. So this gives me negative 2 is less than x is less than or equal to positive 3. Now I'm going to graph this on my number line. I'm going to put my negative 2 and 3. You're more than welcome to put all the numbers in between if you want to. At negative 2, my inequality is just a less than, so that's just going to be an open circle. For my positive 3, that has the or equal to, so that's going to be a closed circle. And my inequality is saying that x is in between negative 2 and 3, so that is exactly where I'm going to shade. So my inequality is saying that negative 2 is less than x, so I'm looking for all the values that are greater than negative 2, which is in this direction. And I'm looking for all of the values of x that are less than or equal to 3, so that's in this direction, which is why you end up shading right in the middle. Okay, number 7 is an or inequality, because you can see your two inequalities separated by the word or. So we're going to solve each one individually. I'm going to divide this one by negative 4. And since I am dividing by a negative, I am going to take my inequality and I am going to flip it. And that becomes a negative 3. So here's my first one. And again, I flipped it because I divided by a negative. For my second one, I'm going to subtract 10 from both sides. That gives me 2x is greater than 10, divide by 2, and this time I do not need to flip because I was dividing by a positive 2. Okay, so my inequalities are saying that x is less than negative 3, or x can be greater than 5. So at negative 3, I have an open circle because I did not have the or equal to. Same thing at my 5. Values that are less than negative 3 are going to be to the left. Values that are greater than 5 are going to be to the right. Okay, number 8. So number 8, I'm going to start by subtracting 4 from both sides. So I have 1/3 x is less than or equal to 4, since 8 minus 4 is 4. And then to get rid of my fraction, what I'm going to do is I'm going to multiply both sides by 3, since it's 1/3. So that leaves me with these 3's canceling. So I just have 1x is less than or equal to 12. I'm going to graph this on the number line. I'm going to put my 12 right in the middle, and I'm going to go ahead and add some values on both sides. And I have the or equal to, so x is less than or equal to 12, so I'm going to do the closed circle. And all of those values are going to be to the left of 12. For number 9, I have negative 3 is less than or equal to 11 plus k divided by 4 is less than or equal to 3. So again, I'm going to look at that middle portion to see how I can isolate k. So I have 11 plus k divided by 4, so the last thing that I said is what I'm going to undo first. So I'm going to multiply all three portions by 4. These middle 4's are going to cancel. That leaves me with negative 12 is less than or equal to 11 plus k is less than or equal to positive 12. I can go ahead and subtract 11, again to isolate the k to get it by itself. And that gives me negative 23 is less than or equal to k is less than or equal to 1. And I'm going to graph this on my number line. I'm going to put negative 23 over here and 1 all the way over here. There would be a lot of numbers in between, but again, if you want to put every number, you're more than welcome to do so. Both of these are going to have closed circles since they both have the or equal to's. And k is in between those two values, so I'm going to shade right in between those two values. And number 10, I have an or inequality. So for the first one, I'm going to subtract 9 from both sides. So I have negative 1h is less than negative 7. Again, if there's no number in front of your variable, it's like having a 1 there, which is why I wrote the negative 1 when I rewrote the problem. Divide both sides by negative 1, and then I have h. I need to flip my inequality because I'm dividing by a negative, so h is greater than positive 7, so there's my first one. And then my second one, I'm going to divide both sides by negative 3. And again, I do need to flip my inequality since I am dividing by a negative. So I have h is less than or equal to negative 2. So my inequalities are saying that x is greater than 7 or x can be less than or equal to negative 2. So at my 7, I'm going to have an open circle, and greater than 7 is going to be everything to the right. And at negative 2, I have a closed circle because I have the or equal to. And everything that's less than or equal to negative 2 is going to be to the left. All right, the last part of your review is just filling in missing boxes. So when we're filling in missing boxes, we either have the inequality and we need to write the number line, or we have the number line and we need to write the inequality. So for letter A, I have the inequality, so I need to write the number line, or graph the number line. Going to go ahead and put negative 2 in the middle, negative 1's over here, and negative 3's over here. At negative 2, open circle. And my inequality is saying that negative 2 is greater than x. So I want to find all the values of x that negative 2 is bigger than. So negative 2 is bigger than negative 3, negative 4, so everything in this direction. For letter B, I do have 2 shaded regions on my number line, so that's going to end up being an or inequality. So for my first one, I have x is less than or equal to, since it was a closed circle, negative 2, or x is greater than 6. And then for letter C, I have my inequality, so I just need to graph it on a number line. I have negative 4, positive 1, closed circle at negative 4 because of the or equal to, open circle at the 1, and x is in between those values, so I am going to shade right in between. Now for letter D, I am missing 2 pieces of information. I am missing both the graph and the interval notation. So I'm going to start by making my graph. I'm going to put 3 in the middle, 4 and 2, closed circle at the 3 because of the or equal to, and this is saying that x is greater than or equal to 3, so all the values that are greater than 3 are going to be to the right. And then for interval notation, it's very helpful if you put your parentheses at the ends of your number lines. So to the right, we approach positive infinity. To the left, we approach negative infinity. And what we're looking at is we are looking at the shaded region of our number line, where it starts and where it ends, always looking from left to right. So my number line, my shaded portion, starts at positive 3, and it's heading toward the right towards positive infinity. Infinities for interval notation will always have parentheses. For the number, you need to pay attention to whether you have an open circle or a closed circle. An open circle is going to be a parenthesis, since you cannot actually include the value. A closed circle is going to be a bracket. So having the bracket there is very similar to having the or equal to for your inequality. For letter E, my x is in between 1 and negative 3. Negative 3 was an open circle, so we'll leave that as a less than. Positive 1 was a closed circle, so we're going to change that to an or equal to. And then for my interval notation for this one, I'm putting my infinities there just because I always do that for interval notation. But for my interval notation, I'm only looking at this piece right here. And it's enclosed. It's sandwiched between -3 and 1. So my interval is going to go from -3 to 1, parenthesis around the -3 since it was an open circle, bracket around the 1 since it was closed. For letter F, another compound inequality, so x is less than -7, or x is greater than or equal to 1. Open circle at my -7, closed circle at my 1. Less than 7 is to the left. Greater than or equal to 1 is to the right. And for my interval notation, since I do have two shaded regions, I am actually going to have two intervals. So for my first one, it is starting from left to right, starting at -infinity and stopping at -7. My second interval starts at 1 and continues to positive infinity. Infinities always have parentheses, and then I'm going to check at my open circles and closed circles to see if I need brackets or parentheses. So -7 has an open circle, parenthesis. 1 has a closed circle, so that's going to be a bracket. And for interval notation, since I do have two intervals, what we do to bring those two intervals together for a solution is we put a U in between. That is the union of those two intervals. So it's just saying that those two intervals together are the solutions to these inequalities. All right, so that concludes this video going over your linear inequality test review. Good luck on your test.